Hello, welcome to workshop number 4, Housing Construction, the role of modern construction method and innovative technology in building SIAH. Our speaker for this workshop are Dr. Jeffrey Mahochi, Head of the School, Civil Engineering and Built Environment, University of Johannesburg, Dr. Temitope Omotayo, Senior Lecturer, Leeds Bucket University.
This is from an international perspective. An international code, this is a document that is used by local, provincial, or national government to control building practice. And it is done through a set of acceptable minimum requirements of building performance. So typically in any building code or a building regulation, this is a legal document. So as opposed to the next slide, as opposed to, if we can go to the next slide, to building standards. On the other hand, building standards, these are technical documents, right? So the building standards, they talk in terms of quality or how to standardize, how to put up procedures, how to put up processes, right? So this is an activity schedule, right, which talks about standardization, right? So we need to be able to differentiate between building code or building regulations vis-a-vis a standard. And the standard is not a compulsory thing, but I will highlight that later on, as opposed to a building regulation, which is actually a legal document. Next slide. Right. So there are various types of standards that you see, right? So, and they depend on the nature, and they depend on the focus, and they depend on the objectives. So you can have standards that focus on products and design, standards that focus on workmanship or quality control, standards focusing on demolition and or recycling. So there are various types of building standards, but as I said earlier on, these are procedures, right? Procedure on how to do a design, procedure on how to deal with workmanship, etc., etc. Right. If we go to the next slide. So if we go into the South African regulatory environment, and let's understand who are the key role players in there. So as I said, the acts that actually impact housing, right, which are very critical in our discussion today, is we've got the National Building Regulations and Building Standards Act. That is your law in terms of the building standards, building regulations. Then we've got the Housing Consumer Protection Measures Act, which regulates the house builders or the home builders and the consumers. Then we've got the Occupational Health and Safety Act, dealing with all the construction regulations. Construction Industry Development Board, I will talk about that. The Consumer Protection Act of 2008. Then we've got the National Regulator for Compulsory Specifications. And there are many other acts, but these are the critical acts that would impact on housing, which we need to be able to unfold. Let's go on. So the key role players, if we can go to the next slide, the key role players that I want to deal with, I want to start off with the CIDB. So the Construction Industry Development Board, who are they? This is a statutory body that was established to promote and regulate and develop the framework for construction delivery capability for South Africa. So it actually looks at developing the capabilities of the construction industry. It talks about making sure that South Africa is competitive, not only nationally, the construction industry is competitive nationally as well as globally. The focus of the CIDB is mainly on sustainable growth. It's about capacity development, it's about empowerment. Right. Its also focus is to look into how can the construction industry performance be improved. It's also about developing the best practices in the construction industry. It also talks about transforming this whole construction industry so that we can have consistent and ethical procurement practices. But more so, it must provide a platform where you can have enhanced values to the clients and society at large. So in terms of the CIDB Act, all contractors and all construction projects that are in the public space must be registered with the CIDB. Next slide. Whereas if we if we then look into the NHBRC on the other hand, the NHBRC, this is a National Home Builders Registration Council. Its mandate is focused more on the home building, whereas the CIDB's mandate is on the broader construction industry. So the mandate of the NHBRC is focused on regulating the home building industry. It is there to be able to establish and promote technical and ethical standards in the home built environment. And it is also there to look into the structural quality so as to protect the housing consumer and the home building industry. All right. Next slide. So in terms of the NHBRC, there are certain technical requirements that every building or every house must actually comply with. And these technical requirements are stipulated by the Minister of Human Settlements, and they relate to structural strength and stability, they relate to serviceability of a building, they relate to behavior and fire, drainage, and stormwater management. Right. If we look at the SABS and then say, okay, so the NHBR, the construction CIDBs for the broader construction industry, NHBRC is zooming into the home building industry, then what is then the SABS? The SABS and its mandate, SABS is just a statutory body which was also established through the Standards Act. The mandate of the SABS is quite simple. They are there to promote and maintain standardization and quality. So it is the SABS that has got the responsibility of writing South African national standards. So their role is to actually write standards, right? And all the other organizations, other entities, they must comply with the relevant standards. So NHBRC, for instance, does not write standards, but it is there to ensure that it regulates the home building industry. All right. Next slide. So the objectives of SABS, as I said, publish national standards. When they do publish those standards, they have committees with industry representatives. They test and certify products which are related to South African national standards. And that point, I think I will pick it up later on. They promote design excellence and provide training on all the relevant aspects that are related to standardization. Next slide. So the South African national standards, and this slide is very important. South African national standards, it provides one solution to satisfy the functional requirements specified by the regulations. So the regulations, they provide the performance requirements, the functional requirements, whereas the South African national standards, they provide the set of solution to satisfy the functional requirements that are specified in the law, in the national building regulations. So it is only one way in which buildings, right, must actually be, if you follow the South African national standards, you are only following one recipe to actually comply with national building regulations, right? Next slide. Then the next organization I look at is Agroma South Africa. What's then the difference between Agroma South Africa and SABS? Agroma, again, I'm pronouncing it wrongly, or so it's a French word which means approval. All right. So this is also another statutory organization, but its main role is to support and promote innovation and development in the construction industry. So the role of this body called Agroma is to provide, its objective is to provide reassurance of the fit for purpose construction products. Right? So any product or material which does not comply or where there are no South African national standards. So South Africa, SABS, they write standards, but they write standards of materials and products where the properties of those products are known. Where you are dealing with products and materials whose properties are unknown and they are not covered by South African national standards, it is then the responsibility of Agroma South Africa to provide the clients, to provide the industry with a assurance of fit for purpose. All right. Next slide. Then the fifth one is the National Regulator for Compulsory Standards, NRCS. Right. This one here is a splinter organization from SABS. This organization used to be there as part and parcel of SABS, but it was split because SABS was a referendum player. So it's now a standalone organization which looks at compulsory standards. It has got many divisions, which includes the automotive, electrotechnical, chemical, food industry. But from our side, as the construction industry, we are interested in the national building regulations and building standards. So they are responsible, NRCS, they are responsible for administering the national building regulations and building standards. So writing of the national building regulations resides with NRCS. Writing of standards resides with SABS. And anything performance related where there are no standards resides with Agroma South Africa. Right. So if we talk about the National Building Regulations and Building Standards Act, if we go to the next slide, right. So all new building work in South Africa, they must comply with this law, the National Building Regulations. They set the minimum standards of performance for all building works, right? So they look at issues around safety, health, stability, habitability of the buildings. And all municipalities are obliged to ensure that all their buildings are constructed in accordance with the National Building Regulations. So that is the law, right? That must be complied with. Next slide. All right. So I'm glad in your presentation, Chairperson, you actually highlighted this slide, but I would want to now repeat this slide in the context of what I have said. So if you look at what is then called then the level 1 structure, the level 1 structure is your constitution. This is the constitution which says everyone is entitled to a decent living, right? Just below then level 1 is your level 2, and your level 2 talks to the national building regulations. The national building regulations, they then give you the functional performance of a decent living. It then talks about stability of a structure. It talks about fire performance of a structure, but it tells you qualitatively. It does not tell you how a structure is supposed to respond to that. Then the how response is then given at level 3 and level 4. And this is where SANS 10400 tells you, which is written by the South African national standards, it tells you how to respond to the functional requirements as specified in the national building regulations. Because the SANS 10400 is actually stipulated in national building regulations, it means that SANS 10400 is also a law because it is referred to in national building regulations. Then SANS 10400, it then tells you how to comply with national building regulations, and it gives you 4 ways in complying with those national building regulations. So the first one, which is level 4, application of rules. Application of rules is the application of SANS. So if you can use any of the South African national standards, you are complying with national building regulations. Or then the other 2 or 3 ways that have been highlighted, the rational design and rational assessments. This is now the way in which a competent person can actually provide design formulations to ensure that the building complies with national building regulations. Then the last one, which is the Agroma certification, is then the third one, which we are interested in this discussion forum. Agroma certification then says, if you can comply with the performance requirements of Agroma, you then automatically meet the SANS 10400 requirements and therefore comply with national building regulations. All right. Next slide, Chairperson. So why do we promote industrialized building systems? All right. And I'm using the word industrialized because some people use the word alternative building regulations, some innovative building systems. But in the context of the previous slide that I've actually shown you, right, I prefer to use the word industrialized building systems, right? Because alternative, you're actually asking yourself, alternative to what? Because this is actually a performance building system. It's a building system that complies with the performance requirements of Agroma, right? And therefore, what I'm actually focusing on is the issues around the industrialized building systems. So what are the challenges? We know the challenges of the current brick and mortar. We know the current slow pace of rate of delivery. We know problems with energy efficiency and indoor environmental quality related to these buildings. Right? Next slide. We also are aware of logistics, especially when we're talking about rural development, provision of toilets and bathrooms, but most importantly, the quality of the final products and the input materials not to acceptable levels. Next slide, sir. So There's also problems with compliance to standards. When you're talking about the brick and mortar, you need to be able to make sure that the house has got proper ceilings and it meets all the 10400 Part XA, the new standards that are related to energy efficiency and water efficiency. Right? Next slide. So, what do we see in terms of the future? I have included all the challenges that are actually there. We are looking into a future where we want to talk about manufacturing high quality products. We want to be able to see designs that address the physical environment, right? Different architectural typologies. We do not want to continue seeing the matchbox type houses, right? We are looking at also fast-tracking quality delivery of the social infrastructure. So we want to be able to see designs that would respond to a range of parameters, the designs that would allow buildings to evolve as the needs of the clients also evolve. Next slide, Chairperson. So when we talk of industrialized building systems, we want to be able to look into technological innovations that would move us from the conventional construction to another level where we can deal with issues around quality, fast delivery, cost efficiency. And that is actually more related to your industrialized building system. Next slide, here. So the most industrialized building systems that we see, they are using the conventional materials, but in a more innovative way. And so we see issues of concrete, steel, timber, aluminum, lightweight concrete, your autoclaved aerated concrete, ceramic products, a mixture of any of these things there, but being used more in an innovative way, right? Giving us the properties that we want. So what are these industrialized building systems? This is a practice of assembling components of a structure in a factory or on a manufacturing site and transferring that whole assembled structure to the construction sites, right? So internationally, prefabrication techniques are used in the construction of apartment blocks and housing developments with repeated units. So there are many types. So you can either pre-assemble it on site, or you can make some of these products here in the factory, either on site or in the manufacturing plant. Next slide. So we are also looking at the use of locally available, and the key word here is local. We want to be able to look into materials the raw materials that are available locally, right? But gives us the required characteristics such as your lightweight, your easy workability, your insulation, combustibility, and all those kind of things. Next slide, sir. So one of the things that, from the perspective of the University of Johannesburg, one of the industrialized building systems that we are looking at is actually 3D printing. 3D printing, we believe then that this technology is going to assist in the fast tracking of housing delivery. We believe that the system, the technology is going to have a reduction in carbon footprint, and it's going to be cost effective. But one of the critical things when it comes to industrialized building systems is social acceptability. And we believe that because of the 3D printing, we are actually using technology that is commonly known, which is your concrete, right? But using it in a more technological manner. Therefore, it will have a good social acceptability, and also it will have it will be bankable with a good resale value. Right? So these are some of the technologies, but there are certain other perceptions still around this product and many other products. Right? The perception still out there is that the quality of these materials is substandard. There are also perceptions about the durability of these materials, that the durability is short term, that the materials are not locally available, that there's problems with maintenance, the cost of the production is still too high, and that there's problems with additions and alterations and remodeling of the structure, and the issue that we are going to reduce the labor force during construction implementation, and therefore there will be job losses. Right? So some of these perceptions here are some of those things that we are busy crafting, and we believe then that all these issues here are just perceptions, but most can actually be dealt with, and that industrialized building systems will provide a much more effective manner in which to deal with these things here. So next slide. So the things that we want to do in terms of that, we want to start rethinking the designs to address these perceptions. So when we're talking about rethinking our designs, we want the mindset of developers, mindset of clients, mindset of everyone else to shift from mass production to mass customization, to embrace parametric modeling for site-specific issues. So if we move from mass production is the same type of typology repeated 1,000 times. But if you do mass customizations for your clients, you are able to customize the needs of each individual, and you do not have a repetitive type of typology, but you're able to actually address a better quality product for the needs of your customers. So we need to have that rethinking our designs. And that rethinking, I think, can only come through some of these industrialized building systems. And more so, if you look at 3D printing technologies, they'll be able to address these problems. Next one. Then socio-economic factors that you need to consider. Again, from a socio-economic point of view, we need to be able to look into the whole value chain. All right? We need to be able to look into sustainable solutions, which are going to be at least 30 years plus. We need to be able to look into technologies that would reduce the costs. And we've seen, and our preliminary investigation of 3D technology has shown then that the cost for producing a house is going to be much lower. The productivity is going to be high. The lead time to delivering the product is also going to be quite acceptable. All right. Next slide. And then to round off, there are many benefits of industrialized building systems that we see. We believe then that with industrialized building systems, we are going to have components that are going to be manufactured through industrial methods, like you're manufacturing your car, high industrial quality using stringent quality control measures, and there's going to be unlimited opportunities for architectural appearances, not one single matchbox. We are going to have modules that have got architectural features such as your windows, your door openings. You can make all different types of architectural finishes. Low maintenance, better predictability of durability, less affected by the adverse weather conditions, and you can also do all your other plumbing and electrical works in the manufacturing plant or during on-site construction. Next slide. And from a waste material point of view, we're going to have reduction in waste materials, low water consumption. We believe that the construction sites are going to be easier to manage. The possibility of converting these houses to bigger houses is going to be much more easier. Increased work sound insulation and thermal properties. So with that, Chairperson, if you can go to the next slide. All right. With that, we are still believing that there are certain other setbacks around industrialized building systems, issues around that the structures may be heavy, right? And that might actually need to be addressed. You might still be requiring some cranes on site, which might be still some of those setbacks. Certain other connections may be difficult, etc., right? So those issues, they still need to be addressed, right? So the last slide, Chairperson, when I go into the AGROMA certification, colleagues, this slide here, I put it deliberately last to just say then that any industrialized building system would have gone through an AGROMA certification. And AGROMA certification requires you to ensure that this product has got structural strength and stability, it performs well under fire, it has got resistance to water penetration, good thermal and energy performance, acoustics, accuracy, quality management. All these things there are embedded. So any product, whether it's a 3D technology or any other industrialized building system, it has to go through an AGROMA certification so that the clients can have a peace of mind in terms of that. Lastly, Chairperson. So in conclusion, I think that construction plays a vital role in creating demand for industrialized building systems. We still need to have good partnership between the private sector and the public sector. Prefab and modular constructions, they have an important role in the future of more sustainable, efficient construction industry. We need to be able to invest in cutting-edge technologies. We need to have innovative industry which is supported by sound research and development. Thank you very much, Chairperson. I know that I might have taken a bit of more time than anticipated. Thank you.
Thank you so much, Prof. It's just interesting things. And later we just come and just ask you to just give us some like updates. What is the University of Johannesburg is busy with that one. So later in the Q&A, we just also try to ask this question. So without further waiting, so we just go to the second speaker, which is just Dr. Timothy. Yes. Can you just unmute yourself? Do you want I share the screen, or you can just share a screen from your side?
Yes, I'll share my screen from my side. So I'm Temi Tokwe Omotayo. Right? Temi Tokwe Omotayo, not Timothy.
Sorry for that.
All right, okay. So I'll share my screen from my side, and I guess everyone can see my screen. I'll just share. Right. Can you see my screen yet?
Not yet.
Okay, just a minute. All right, I guess you can see my screen now. Yes,
we can see.
So I will just maximize so I can start. So hello everyone, you're welcome to today's presentation. My name is Temi Tokwe Omotayo, but you can just call me Temi for short. And I'm a senior lecturer in quantity surveying in Leeds Package University. I'm also part of this project, the Sustainable Innovative Housing in South Africa project as a UK lead. And today I'll be speaking about understanding the costs of innovative affordable housing, innovative sustainable housing, and lessons from the UK social housing project. So in today's, it's a bit frozen. Okay, so in today's workshop presentation, I'll be going over some just very brief steps because I'll be speaking for about 30 to 35 minutes. So I'll be looking at the technology. Apologies.
Can you please unmute?
Sorry, can you please mute? Can you please mute them, please? Okay. Okay, so in my outline, I'll be speaking about what the modern methods of construction in sustainable social housing in the UK is all about, and I'll be speaking to you about the costs of social housing and innovation in the UK very briefly, and looking at strategies that's been used to minimize the cost. And also I'll give you examples of a breakdown of the cost and how we get the cost data to apply in future projects for social housing. So basically in Africa, we call it low cost housing, and at times we call it sustainable affordable housing, okay, as a major term which we're trying to coin right now. But in the UK, we do have the term affordable social housing. Okay, so it's houses constructed by the government for those people who cannot, for the classes of people in the society who cannot afford housing. Okay, so at the end of this, I'll be giving you lessons for UK sustainable housing for the framework for housing development, which we're still working on. So basically, we're going to be looking at four main categories of what modern methods of construction is all about in terms of sustainable social housing. So we'll be looking at it from the perspective of technology, and I'll be talking about building information modeling, and I'll also be talking about sustainable homes, or what we call the green homes, which is emerging right now. And we have several certifications, which is BREEAM, LEED, and EcoHome, and other types that I will just introduce you to briefly. Then we'll be looking at the materials and processes, which was covered by the previous guest, so run over that very quickly. And finally, we'll look at a cost database, which is the main point highlight of this presentation. And I'll be looking at the Building Cost Information System, BCIS, which is a major cost database applicable for determining the cost and the floor area and sizes of buildings. So basically, building information modeling and the UK became very, very popular right from the 2000s. And in 2011, the UK government created a BIM mandate, right? So the BIM mandate was for all public funded projects, all government projects in the UK to apply BIM level 3 by 2016. So this mandate came up in 2011 for a 2016 target for all public funded projects. But basically, you could ask me, what is BIM? BIM is not a software, although many people say, oh, BIM is a software application. No, the digital tools are just applications under BIM. So BIM is a process of creating information models containing graphical and non-graphical, graphical in terms of drawings and non-graphical in terms of Excel data and other forms of data in a common data environment, which is shared for digital project information. So the key term common data environment refers to that common platform, like a SharePoint, like a OneDrive. Or in the UK, we use a platform called Trimble Connect, where all the drawings, the COBie data, the Excel spreadsheet and everything is kept within a common platform where everyone else can log into and share and adopt and make use of. Okay, so there are different levels and applications of building information modeling in terms of dimensions, BIM dimensions, which I'll look at, and I'll be focusing on the cost aspect. But before I go to the cost aspect, I'll just show you the BIM framework that's mostly applicable within the UK. So starting from the right-hand side, top right-hand side, and going downwards, okay? So it starts from the employer, the client, a certain document called the Employer's Information Requirement, EIR. It used to be known as Exchange Information Requirement in the past. And this document is prepared by the employer, the client, but not just the client alone, in conjunction with the suppliers and the key stakeholders, right? For the procurement process, for the contractor selection, okay? Now, further documents are prepared by the stakeholders called the BIM execution plan, which then leads to the award of contract after the contractor has been selected, and the contractor, who is the appointing party under the ISO 19650 standards for building information modeling, prepares a document called the Master Information Delivery Plan, MIDP. Now, this process goes on using what we call the RIBA plan of work. So in every construction process, you have several stages. Okay, so in the middle of this chart, you can see the stage 1 up to stage 7. Stage 1 is like the briefing stage that you find in the RIBA plan of work. RIBA is the acronym for the Royal Institute of British Architects, and it has a kind of framework which shows us a guideline of how the construction process will flow throughout the life cycle of the project. So it's also embedded in the BIM framework for the UK. And this entire process, I'll just go here. This entire process can be simplified just like this. Okay, you have the EIR, which is the Employer Information Requirement, prepared in conjunction with the client and suppliers and other stakeholders, just to define their brief, more like the briefing stage, and goes on to just a stage where we call the BIM protocol. Okay, so this is the agreement between the parties to have some detailed level of information for the construction process also and execution of the project. But it moves into the in-use phase where we have the asset management, operation and maintenance. Okay, so in the operation and maintenance phase, you still need to use the previous data, graphical and non-graphical data, to regularly maintain the asset, regularly maintain the property, right? So this kind of process is very comprehensive, very detailed, and that's why we have experts called the BIM manager that helps and facilitates the process of preparing this document and ensures that the entire BIM process is very, very effective right from the beginning up to the end. So I'm just going to be going into the aspect of costs right now. Now, the reason why I mentioned BIM is because building information modeling is one of those major construction, I would say modern methods of construction technologies that has been very effective in delivering sustainability in all regards. Okay, and that's why we have different dimensions of BIM. Now, the first dimension is the one which is just based on a scratch point, not much information in place, conceptual designs. Now, the second dimension is more like a 2D drawing, using your X and Y axis to just prepare a 2D drawing on paper, and you have all the details in terms of the 2D level, the regular traditional way of constructing, if I should say that. Okay, but when it gets to the 3D, that's when you have a three-dimensional drawing, graphical data, X, Y, Z axis, and you have more visualization, you have more clash detection. You can know where the electrical will be going to within the building and detect and see if there are going to be some level of errors within the building or the sketch, within the model rather, and then we can then bring in more detailed level of sustainability. Okay, so here we can do some level of simulation to determine the daylight saving, the energy performance of the building. Okay, and when we go to the BIM level 4, we can then start including more visualization in terms of construction planning, program of works attached to the 3D model. Now, the 5D model is what I'm particularly concerned about, that I've been doing a lot of work and teaching on, is the 5D BIM. Now, in 5D BIM, we use certain applications like Costex, Exetel Costex, which is known as the I2 Costex. We use Bluebeam and a lot of software to take out quantities from, a 3D model. Okay, so the quantities are extracted from a 3D model, and it helps in contract formulation, it helps in preparing the bills of quantities, and it aids and helps in the preparation of the life cycle costing. Okay, not just the present cost, but the future cost and planning of the project. So all in all, we do have 6D BIM, which deals a lot with the value engineering aspect and other cost saving measures. Now, in recent times, you also have the 7D and 8D BIM, which looks more on sustainability and health and safety. Okay, so you need to probably check out the 8D BIM, but I don't want to go into that. What I want to focus on right now is the 5D BIM. So what is 5D BIM? 5D BIM just pertains to how we're able to extract quantities from 3D model, and not just the extraction process, the accurate, more detailed extraction process. Normally in our 2D drawing or 2D BIM, we do have a process where we do manual taking off, manual measurements with our pen and paper sheet, and we'll extract the quantities, but there are a lot of errors, there are a lot of mistakes attached to just taking out quantities and building up rates manually. Okay, the rate is what we use to multiply against the quantities to get our final cost. So without 5D BIM or a kind of digital to take out the quantities in a drawing, it is always very laborious and it's always filled with errors. And at the end of the day, we have instances of estimation error, cost overruns, and a lot of things that has to do with claims on construction sites and probably disputes. Okay, now the advent of 5D BIM has provided an opportunity for us to go into how we can, you know, produce bills of quantities very easily, and the process takes a lot of expertise. So I mentioned earlier that we have our BIM manager. The BIM manager could be an architect or a designer or someone that has a lot of expertise in providing graphical drawings for projects. Now, the process of 5D BIM and information exchange goes on in such a way that a quantity surveyor, just like in the past where we can query certain drawings and get some level of drawing, which are conceptual drawing, not detailed drawings, to produce cost estimate, okay? We'll always get in touch with the architect or the designer to get some level of information to produce our cost analysis. Okay, that same information exchange is also very, very common and very vital in our process of collecting quantities and developing our cost plans in 5D BIM. However, the benefit of this is that at several levels of development, so the LOD means levels of development of design, okay? The QS can start producing the initial cost analysis, first cost plan, okay? Up to the final level of development, the LOD 500, where we produce our bills of quantities. So this process itself, apologies, I think I'll have to wait that. So this process itself is able to make things easier for everyone else, particularly the quantity surveyor. Now, the other aspect of sustainable housing is the energy ratings of buildings. Okay, this is another aspect, and I will mention why this aspect is very important. Energy ratings of building accreditation. There are a lot of building accreditation over the years, like SAP, but the major ones are really taking hold right now. Still the BREEAM, that's the Building Research Establishment Environmental Assessment Method, the DREAM, which is for the Department of Defense. Okay, so it's a defense related assessment, environmental assessment method. And you have the LEED, which was very common in the US, still very common in the US, but becoming very common in the UK. LEED is the leadership in energy and environmental design. And we have the eco home and BIM compliant homes. So why do we have this kind of energy ratings, and what do they really do? Okay, now what these ratings do in terms of construction management, the building is assessed overall in terms of its process, in terms of its well-being for health and safety, in terms of its energy efficient in utilizing energy resources, and in terms of transportation, okay, which is set for maybe the buildings are set in connection to locations to public transport. They're also assessed in terms of water utilization, and also in terms of materials, building material life cycle adopted within the entire construction process. And more importantly, waste reduction, okay? So we want to know if the materials are set to make sure they don't build up a lot of construction waste and minimize waste during the construction process and also during the in-use phase of the building. Then the health and well-being also looks at biodiversity and the environment. Pollution is one of the things that is looked at in in most of the ratings, and definitely innovation. Now, the connection between sustainable energy ratings of buildings and cost information is such that we want to reduce waste. And in us reducing waste, in us enhancing rather the sustainability of buildings, we need to achieve certain things, right? We want to reduce construction program time. We want to reduce construction costs. We want to reduce on-site labor. And some of the techniques that we use is off-site construction, prefabrication. And in the process of off-site construction and prefabrication, we do have what we call the design for manufacturing and assembly, which is major in-depth in off-site construction. So basically, yes, I heard the argument the last time that if reduced labor on site, is it not going to create unemployment? But the answer is no, it's not going to create unemployment. It's actually going to create more jobs for many people to come on site, because by the time you finish one project very quickly, you can move on to the next project and get many other people involved in so many projects. Okay, so when you have multiple projects in place, it's likely that you have more people to come on the factory floor, more skill acquisition on the long run. Okay, that's one of the benefits of having sustainable construction using off-site manufacturing as an embedded part of it. So going into the construction process in the UK for social housing. Social housing in the UK accounts for just 17% of the housing market, and it's basically an alternative for people who cannot afford their own homes, and is constructed by the government. And in recent times, in the last couple of years, 5 or 6 years, they've been considering modular homes, which is a very good alternative. And it's a form of volumetric construction where the homes are built in volumes of maybe 5 meters square or just 3 meter square spaces, and they are taken in modules and placed together or combined together on site, if I should use a very basic word. Okay, so the meter square size is one of the things that is very important when defining modular homes for meeting up the backlog of social housing in the UK. Now, very quickly, I'm going to go in depth now into how we do assess the costs of modular homes or social housing in general in the UK. So in 1961, the Building Cost Information Service, BCIS, was established. Now, BCIS is a database which stores tender prices, contract prices, sizes of building, cost-related information related to buildings since 1973 up till now, okay? And it gives us ability to easily get early cost advice, produce elemental estimating, have cost-related information, do some level of research in terms of costs before we then go into how the building should look like. Okay. Now, one thing about Building Cost Information Service is that it's very good for what we call design into cost. Okay. There is something called cost in the design and design into cost. So let's assume that the client is a government or someone who has very limited funds and only want to construct a building that's just what, £80,000 or maximum £100,000. I'm using pounds because I'm in the UK and used to that currency. So let's assume that's the benchmark, okay? The cost has been given as a limit and they don't want to go beyond that limit. They can actually come to BCIS and find a gross internal floor area space, just a floor area space that covers that cost limit all alone. So you can then determine if you'll be having 500 or if you'll be having 80 meter square space or 50 meter square or 100, maximum of 100 meter square floor area space to give to the designer. And the designer, the architect, would then have to produce designs based on this cost. Now, BCIS helps us to do a lot of cost analysis to easily get the best meter squareage to give to the designer to design our sustainable home. That's the purpose of BCIS in short. So now in the UK, we have several standards like the new rules of measurement 1, 2, and 3. Now the new rules of measurement 1 helps us in our cost planning. The new rules of measurement 2 is a detailed measurement for bills of quantities, and the NRM3, new rules of measurement 3, helps us in our life cycle and maintenance costs. Okay, so I'll just give you all that because the main parameters we use in BCIS are taken out of the context of NRM1, new rules of measurement 1. Now, within the first pages of new rules of measurement 1, when we're trying to calculate our cost plan, we look at the word element, building component, roof, wall spaces, and floor structure. Then we look at the elemental cost estimate, which is us trying to find the estimate of that element itself. And the breakdown of this is just using our elemental unit quantity against our elemental unit rate. So what is the quantity approximated of the wall spaces or the roof spaces? Okay, we can determine this in terms of meter squares. Always have to be converted to meter square, even though you could have it in meters or meters cubed. And we need to also find our elemental unit rate. So once you find your elemental unit quantities and your elemental unit rate, you multiply elemental unit quantity by your elemental unit rate, right? This is meant to be EUR, not EUQ, apologies for that. And then you can have your elemental cost estimate. Then we can also use our gross internal floor area spaces of the building against the elemental unit rate to get our cost per meter square for the gross floor area. Okay, so I will show you an example of this sheet later on. Now, just a quick case example from the Building Cost Information Service. In the database, we have so many options. We have options to select public or private building, any type of building, basically, but definitely residential building is social housing. Okay, we can also select the type of building accreditation in terms of sustainability right here. I didn't expand that. And we can also select the type of specification which we are looking at. Maybe we're looking at timber or concrete or steel related building. We can select the specification if we're trying to get our estimate. Then we also need to rebase. Rebasing means you are converting the old prices of 1973, 1980s, 1990s, the 2000s for our quarter of the year in 2001. And you can also choose a location factor to know and determine where your construction will be carried out. Okay, so in short, you will have a result page where you have a very quick summary of what you'll be receiving. Okay, you have a quick summary that looks like this. I couldn't take the master screenshot, but you would have up to 10 results, 20 results in most cases, and you can select if you're even going to be finding your building, your previous old building, in terms of the total building cost, elements. If you need drawings, previous drawings, you can also look for it through this database, and also with elemental quantities. Okay, so I selected elemental quantities and I selected a type of building. So if you click on one of the buildings on this list, this was not the building I opened up. I just opened this up. You have the first building looking like this. Okay, you find the project details. You can read it and see if it's a type of building that is quite similar to what you'll be working on. So if I notice that this building is very similar to what I'll be working on, I can select up to 5 or 6 of them, and the details of each of them will have the elemental cost breakdown. So this elemental cost plan is similar to the standards set by the Royal Institute of Chartered Surveyors, RICS, and RICS producing New Rules of Measurement 1. So remember, in the past, I was explaining the elemental unit quantity, elemental unit rate, cost per meter square. Okay, now what we do is that we take the gross internal floor area as a major element, okay, and we can multiply the gross internal floor area by the cost per meter square to have this cost. Or if you multiply this elemental unit quantity by the rate, you should be able to have this cost. And the elemental cost plan gives us a percentage distribution of all the costs up to the end, even up to preliminary works, external works, and every other thing. So what we do with BCIS is that if I take this elemental cost breakdown for a particular building, which is very similar to the one I'm proposing, okay, I can take averages, which is rebased, okay, I can take averages of this rebased cost plan of about 5 or 6 or 8 similar buildings and try to find out my initial costs. Okay, now at this stage, I don't have complete drawings. That is why I'm using previous project and previous costs to estimate my likely construction cost. Okay, I have a conceptual design. It's assumed you have a conceptual design, and it's assumed you are trying to determine the floor area space or how the building project will look like. So you can also have specifications, detailed specifications of previous projects within the Building Cost Information Service. And all in all, I can use the BCIS to read and find out, was my building sustainable? The building I'm trying to assess to use in my averages to compute my total cost. Okay, so it's a 4-number building, semi-detached, and it uses Code for Sustainable Homes, level 5, and it uses strip foundation, pitched timber roof, timber external windows and doors. Okay, so I can see the floor area, ground floor, upper floor area, total floor area as being 424 meters square. So if I'm not okay with this description, I can select another option. But within BCIS, you will definitely see many options you can use to create your sustainable, affordable homes. Okay, so the reason why I showed you this process is that In the UK, it's easier for myself, being a QS, a cost expert, to get access to BCIS. Although BCIS is quite expensive, we have a subscription of up to £7,000 in a year for BCIS. So it's mostly universities and large organizations, city councils that can at times afford it if they need it. Okay, but if you're a very professional PQS, professional QS involved in cost planning, you will likely need it because you'll be doing a lot of work related to cost analysis. Now, the lessons for African countries and South Africa is that building information modeling mandate is required by the government. I always say that if anything good wants to happen in Africa, it should start from the top. You can really start from the top if they enforce it. Okay, so if, just like the UK, they try to enforce public projects to make use of building information modeling, although there are private companies that I've met with and they said it's very hard, and they know how to use BIM, but they cannot implement BIM because it's not fully integrated with the supply chain as a major problem for private construction companies in the UK. But if the government made sure that every public project is making use of BIM, African countries can do that. They can have a target, a BIM mandate. All construction projects in African countries should have some level of BIM implementation, even if it's the BIM maturity level 2 or 3D BIM, 4D BIM at least. Then the building accreditation ratings needs to align very well with every other aspect of building construction, especially with building information modeling. And African countries need to ensure that we work very well on our building accreditation ratings to enforce it, not just to have it in place, but also to enforce it. Okay, then at the same time, a cost database is very essential. Okay, there are some countries in Africa that has a cost database, but it's not in-depth. It is not, it only gives you indices. I've had a look at the one in South Africa and other countries in Africa. It only gives you indices. It doesn't really give you breakdown of elemental cost, right? So the government can also come in here, or professional bodies can also come in to establish cost databases that gives us or that mandates construction professionals and contractors to deposit their already completed contract documents, especially the elemental cost plan, okay, total building cost. Then affordable housing should always go along with building information modeling. That's where the whole world is going towards. Okay, building information modeling and sustainable affordable housing cannot be separated right now. They're moving along together, and you have terms like circular economy creeping up. Circular economy and building information modeling are new concepts that are helping us reduce waste, or reusing construction waste on other sites again, all right? Or maybe reusing construction waste in off-site manufacturing. Okay, they are emerging concepts, but it's really been embedded within BIM. And more application of building modular building construction and design from manufacturing and assembly is required in Africa. So we have the potential, we have the capacity, we have the material. We just need to get more seriousness from the government, because the government can mandate things to happen. There are a lot of public projects. Okay, so if the government sets the right example to public projects, using modular construction, off-site construction, design for manufacturing and assembly kind of approach, it's really going to make things much more easier and fast track for everyone else. Thank you very much. That's the end of my presentation.
Thank you very much, Dr. Ometu. We have a few minutes time for the Q&A. So I just try to open the floor to everybody. They can come and just ask the question instead of I just read the question. Yeah. There are few interesting questions in the chat, which I just collected that one. But if anybody wants to just unmute themselves and just talk or just ask their question or the comments, they are just welcome to do that.
Yes, Graham here for Debbie and the engineer earlier on. Interesting topic and obviously very welcome. Australia has a lot of similarities with our remote social housing for our indigenous population, if you like, in some really remote areas. In Australia, there has been some pushback from government to make BIM, for example, mandatory across residential projects. So current status, as I understand, is BIM. Any major government projects will be mandated for BIM, obviously for various reasons. I wonder if, for example, in the South African context, if we're going to build a housing development with, just say, 1,000 homes, either modular or prefabricated, off-site, and utilise the labour as we've just discussed, which is very efficient. I appreciate the benefits of cost control and the like, but really, what would be the benefit? How do you sell that to government? To say, here's the benefit. What's the benefit going to be? One to the government and one to Joe public, who will either rent to purchase or one of those types of policies. So I guess I missed out on the first three discussion points, but I see that maybe as a stumbling block. Government needs to be really committed to the social housing, sustainable housing process. So happy to hear what you have to say, Timmy.
All right, thank you very much, Graham. So yes, the government commitment on social housing. So yes, they want to know the benefit. They want to know what they will gain at the end of it. The benefit of being has. I don't really know where to start when I want to start talking about benefit of BIM, but it aids a lot of cost reduction. There are a lot of things in terms of, cost overrun is one of the major challenge in construction project. So although BIM has not eliminated cost overrun, but it has really helped in reducing it, helped a lot in reducing it. And issue of dispute, issue of delivering projects on time, issue of having an established framework, a very comprehensive framework that you know is efficient. Okay, so if there is going to be a pitch to the government in South Africa on how we can use building information modeling to enhance affordable housing, we need to let them know the benefit in terms of that cost reduction, let them know the benefit in terms of sustainability, waste reduction in itself, the benefit in terms of delivering projects on time, getting more houses constructed. Same thing too also with modular buildings, modular construction, where you have buildings constructed and modeled in the factory before it's transported to the site and placed together. Well, I feel the government needs to be well aware that many parts of the world, particularly the United States, is adopting that to meet their housing shortfall in many states in the United States, and basically using BIM and modular off-site construction to meet their housing fall. So if they see the benefits and the way other countries, other developed countries, even China, even China is using it, the way they are able to put their buildings together. I'll just give you an example. If you look at last year, rather 2019 or 2020, when the COVID-19 issue started in China and they had to construct an hospital within a space of very short time. And people were surprised that the hospital was already in place within a month. A very large hospital. They use prefab and they use BIM and they use modular form of construction, and he had it in place in an emergency. So Well, in Africa, it might just be the expertise that is a problem and the full awareness of BIM on the part of the government. Now, those in government might be aware, but might not actually be aware in terms of knowing how to go about implementing BIM. So academics and construction stakeholders in Africa need to engage political office holders in terms of the benefits. That's what I can say. Thank you.
Yes, thank you very much.
Graham still has a question.
Oh, you.
Can I just add one more? Would it be then feasible, and I'm aware of the social context and whatever that happens in South Africa, would it be then feasible to just use Cape Town for example, to take a project somewhere in the Cape there, and we'll just say build 10 or 12 homes, sustainable, prefabricated, and build that and use that as the model, use that as the test case.
Yes.
Rather than try to say we want to build 1,000 homes.
Yes.
So there's a model of 10 or 12. Easily say this is going to be, we can have a type 1, a type 2, a type 3, on different layouts, as you know, and we say, right, there's the cost analysis for that type, that type, and then we have a model that you can sell. I'm just thinking outside the square here to push that along.
That's a major way. That's another way. Building prototype, building samples, showing government samples, and letting government know the experiment. The government would want to experiment to know if it can actually work. So we want 5 prototypes or 4 prototypes, and then assess it in terms of the time cost and quality and sustainability to see if it's something they can fully implement in the long run. Yes, that's a very fantastic approach. Yeah, I agree.
Yeah, and if I just want to add something from the South Africa perspective, before the COVID, we just try to make it compulsory, level 3 for the infrastructure, especially those funded by the government. But unfortunately, we just impacted by the COVID, and that plan is just postponed to some time that I don't know time. But linked to the 3D printing, if you want to just go for the 3D printing modular, as you mentioned, without BIM, we cannot do that one. So this is exactly the things we just try to do it. So we just try to invest on the BIM and just put it on connected to the other innovative technology, or as the Prof. Maichi just say, industrialize the construction in the Africa. One of the big issues we have it in the South Africa, we don't keep the information from the even newly built building. So the building is just finished a few years ago, but we don't have any blueprint, we don't have any as-built, we don't have any information about the building. And now it's just a problem. And majority of the building in Africa, you just see there is just poor maintenance because of the lack of the information. I believe the building information modeling team has a very good potential for the South Africa. Maybe at the beginning, it's just difficult to just adopt it because of the level of the awareness, as you mentioned, or maybe because of the initial cost of this technology. But definitely in the long run, it's just very effective and efficient. I see the hands of the mercy. It's just, you want to unmute yourself and just make your question or the comments.
Can you hear me?
Yes.
Okay. Good afternoon here, and good morning, good day to everyone in different parts of the world. I want to say thank you to the organizer of this workshop, everyone, and also to all the presenters today, Dr. Jeffrey and Dr. Temitope. My question goes to Dr. Temitope. Thank you for the presentation, quite insightful. My question is with regards to BIM, the awareness call implementation in Africa, South Africa, and also with regards to the modular, sustainable, affordable housing. Is there any consideration about the ownership of BIM? Because I know it formed a kind of debate in the Western world, and it's a debate, and even in the academic environment too. There has not been maybe a forthcoming resolution to that. I know that BIM has its own advantages, but I'm looking at, okay, the challenges that the Western world is facing now with regards to BIM. Since it's coming up, how can we address it with, I mean, as we're trying to implement it or trying to consider it in modular construction in South Africa? Thank you very much. That's my question. Thank you.
Sorry, I didn't get the last part of your question. You said?
So I said that since it's a form of debate in the Western world, the ownership of the BIM technology, it's a debate in the Western world now, irrespective of the advantages that the BIM comes with. It has its own advantages, and for the government to mandate building construction. So it's just the ownership aspect of it I'm looking at, because we're looking at affordable to, I mean, the low class people taking part in this housing. How do we address the ownership, since it's a debate already in the Western world construction? Thank you.
All right, thank you. Now, if you check, there are standards for building information modeling. You have the ISO standard 19650 version 1 and version 2. And within that ISO standard, you have what we call, they defined who the owner is. So the ISO standards are more like the standard form of contract in a way, or kind of template. Not really the standard form of contract, but kind of template that defines who the actor is, who the owner is, who the employer is, and who are the appointed party and appointing party. Okay, so now if you check the ISO standards, they've clearly delineated and clearly defined who will be the owner. Now, if you're looking at this debate, I've seen a couple of debates online, and what I always want to do is that you can just go and find ISO standards that clearly defines ownership in terms of building information modeling. But when you come into Africa, that issue of ownership can definitely crop up, and it's always good to create a form of database for everyone to have access to data, graphical and non-graphical data that was produced by everyone else. Okay, so if there's a common database, not just a common data environment right now, a common database for building information modeling, they can have a shared ownership. So shared ownership can actually solve the problem and debate of who owns what and who doesn't own this or that, especially in developing countries. Is that okay?
Yes,
so
thank you very much. Yeah.
Proposal to have a shared ownership database, such as the Building Cost Information Service, although SIAH is just mainly for cost data, but it's accessible to everyone. But even developing countries are still working on that ownership issue. But yes, a shared ownership will really solve a lot of constraints. Thank you.
Yeah, I agree with the ISO 19650 just clearly explained that one, and we need to just consider that as a shared environment, because we need that information for the operating the building. Facility manager need to have access on that one. You know, those owners, they need access, the tenant need access to that kind of information. But how we just limit the access, who has the access to the whole information, is just clearly explained in 19650 ISO. So it's just a very interesting debate on that one. And few cases we have it in the South Africa. We are just constructed already building with the BIM, and so far we don't have that kind of a problem with the ownership, because in the build protocol at the beginning of the project we just agree who will be at the end of the day will just be the authority or the ownership of this building. So it's just very important, as Doctor, you just mentioned that one, to specific and just make the details in the BIM protocol at the beginning of the project. What is the role of each player and the stakeholder, and what is the level of the access or the level of the information they have from this database. They just have that. I have one interesting question in the chat regarding the 3D printing. They just asked Dr. Mahichi, is it possible to use the mining vest for the 3D printing, use as a material for the 3D?
Yeah, thanks. Thanks. Yeah, I'm not very familiar with the material, but that is being asked. But one would guess then that you would need to actually do a proper material characterization. You see, the problem with the material that you use for 3D printing, it has got certain other properties which is not like your ordinary concrete. So it must have all these things of a good, it must be able to gain strength in a very, very short time period. Because remember, when you are printing up a house or any building, right, by the time you come back to the first point where you started pouring that material, it must have gathered enough strength for the next layer of material to be deposited. That's one thing. Then the second thing is then that also the flowability of the material, as well as the ability of the material to be pumped. All those characteristics must actually be investigated for the suitability of the material. So if one has got any material that they have, we are also open to investigate such type of materials. We are busy looking at the possibilities of using other geopolymers in the 3D printing machine, right? So the opportunities are wide, and if they can comply with certain parameters, then one can be able to use that material for 3D printing. But having done all those things, and probably in my presentation, I know I rushed off my last slide, but the product must be able to be certified by Agroma South Africa, which means then that the material itself, after you having built the wall or any product, you must be able to test it and see that it has got the good structural strength, right? It must be able to be durable for the next 30 years or so. Water penetration issues must be there. So they are quite in fire. It must also be able to extend fire for the next 30 minutes or so and be able to make sure that people can evacuate the building within 30 minutes or so. So there are quite a number of tests that one would need to do. So you cannot quickly rule out that this material cannot do, right? But you might be able to use that material as a composite with other materials to find the new properties that you require. Right? So if one has got any interest, I've seen in the chat a number of people asking different materials. We can engage on that, and then we can see how those materials actually behave and whether they can be used for 3D printing. Thanks, John.
Apologies. Can I, Ali, can I leave now? I have a lecture by 1 o'clock that I need to prepare for. So... Can
I just see if it's just last question from your side, because I see a lot of interesting about the
All right.
Last question from the Dr. Omoti. Is there any last question? Oh, okay. Thank you so much.
Thank you. Thank you very much.
Class, but you are part of this project, and see a lot of good interest. So maybe we just make another workshop to just focus on the BIM, so we can just discuss more. Thank you.
Thank you. Bye-bye.
Sure. Thank you. So is there any other question? If it's just a last question, I'm just happy to just get the last question. So either myself or the Prof. Maichi just able to answer that one. Is there any last question or the comments? Okay, thank you so much. So there is no question. So we are already 3 minutes past 2:30. I appreciate all your time and your attendance. And I hope you found this workshop useful and interesting. So the next workshop will be happen on March 31st, which is about the housing environment. And we are just discuss about some of the issue which Dr. Omotio or the Professor Mahichi highlighted about the environment issue of the housing, especially the current situation of the affordable housing in the South Africa. And we're just glad if you can just join us. Thank you again for your time. We just appreciate the time of the speakers, and the slides and the record will be available by tomorrow in the SIAH website. So please log in the SIAH website and just you can download the slide of the both speaker, and all the records will be also available. Also the previous records and the slide is also available there if you want to just watch the previous one. Thank you so much and hope to see you in the next workshop. Keep safe and bye.
Thank you, Doctor, and bye.
Thank you, Bye.